Welcome. This is Stephen with Service Plus Solutions, and I'm here today with a conversation with David with Electrician Ed again. And on this topic, we have a 3-video series about dedicated circuits. And so I'm going to tell you dedicated circuits come into play when you have a specific electrical appliance that uses quite a bit of power. And there's a couple other reasons that may apply why you need a dedicated circuit. And so there's a question of, does this need a dedicated circuit? That's what we're going to dive into. Our 3-video series, this first video is going to be, what is a dedicated circuit? We're going to talk, what is it? Why is it important? And then as far as the code is concerned, which appliances are specifically called out to have a dedicated circuit. On the second video, we're going to go over, there's many other appliances that aren't specifically called out in the code that are going to need dedicated circuits. And there's a process to determine which one of those need it. So that's going to be in our second video. Our third video, we're going to go through a list of common appliances, and we're going to tell you, do they need dedicated circuits or not? I'll give you the punchline. Most of them, the answer is not yes or no. It depends. So there's more factors that come into play, and that's why we have electricians that were trained, and electricians can look into our code book and things that we're not sure about. But we can also assist you, not just in the safety aspect, which is what the code says, but also in the convenience aspect. We don't want you tripping breakers to have a nuisance or blowing fuses. We also don't want you to forget things as you plan maybe a kitchen remodel, the layout of your room and things like that. So all these factors go into play, and why we're, as electricians, we're here to assist you in the process. But these 3 videos on dedicated circuits will give you a good start, a good look into what all goes into play. So here we go as we... Welcome again. This is Stephen with Service Plus Solutions, and I'm here with David with Electrician Ed. And once again, this series, we're talking about dedicated circuits, mainly in a residential electrical system. So our first video, we talked about what is a dedicated circuit, why there's a little bit of confusion about the terminology. Why is it important to have dedicated circuits? And then what items were specifically called out by the code, which electrical loads were specifically called out by the code to have dedicated circuits. And we mentioned on that video that there's many more appliances that you're going to have dedicated circuits on. And so in this video, we're going to go through the process of what determines what needs to have a dedicated circuit. That qualified electrician is going to be familiar with this, and a homeowner can be familiar with it as well. It's a lot of it's not that complicated, stuff that's readily available to you. The third video, so stick around for the third video if you're not interested in learning this process. The third video, we're going to talk about specific appliances. Do they need a dedicated circuit? Do they not? And there's going to be some gray area in between there. And so the gray area will refer you back to this video. Mm-hmm. So, David.
Yes.
Those appliances, those electrical loads in our house that are not specifically called out by the code, how do we know if they need a dedicated circuit still or not?
Okay. I've kind of put together a little step-by-step approach that you can use to determine that. Number one, you have to do what the manufacturer says. So if it calls for either a dedicated circuit or an individual circuit in the manufacturer's instructions, that's the end of the discussion. You have to do what the manufacturer says. According to the NEC, and I believe that rule comes because it's also got a rule that appliances over 50 volts have to be UL listed or just listed by a listing agency. Mm-hmm. If you go to UL list their listings, and
you meant 50 amps, correct?
Excuse me, 50 volts or higher.
Oh, 50 volts. Okay.
50 volts or higher has to be UL listed. Okay. So that's going to cover most appliances in most American homes, at least. Um, you could have some low voltage stuff that wouldn't apply, wouldn't have to be UL listed. It's still a good idea to go according to the manufacturer's listing, though. But as far as the NEC is concerned, that it has to be listed. Okay. The second part of that is that the NEC says you have to do what the manufacturer says, and I believe that's because UL says that you need to do what the manufacturer says, because they test it that for those parameters, and then when they say this is listed for a specific use, the use is explained in the manufacturing instructions.
Mm-hmm.
Okay. So beyond that, the second step is you need to use the process of elimination to determine if it needs to be dedicated. Okay.
Mm-hmm.
So the rules there are for multiple outlet branch circuits
Mm-hmm.
that have several loads that they're servicing. Okay. Um, and by the way, an outlet, here's some terminology that we'll use. An outlet is a point on the electrical system that you can tap into to get electrical use. Okay. It could be a receptacle outlet, it could be a lighting outlet, and it could be a hardwired outlet where it's just the appliance is hardwired right into the branch circuit at that point. Okay, that's an outlet. A switch is not an outlet. And the receptacle itself is not an outlet. A receptacle outlet is an outlet. Okay. So with multiple outlet circuits, if a single appliance is rated for 15.1 amps, you're not supposed to connect it to a circuit rated for only 15 amps. This is rule number one. The branch circuit has to be able to supply the same amount of electricity as what the equipment plugged into it is rated. So you wouldn't put a 20 amp appliance that's going to need 20 amps on a 15 amp circuit.
Yep.
Okay. And you should trip a breaker if you do. Next, for 15 and 20 amp multiple outlet branch circuits, any one piece of cord and plug connected equipment cannot be rated more than 80% of the branch circuit rating. So
Mm-hmm.
for example, if you have a 15 amp branch circuit, and that means your breaker or your fuse says 15 on it,
Mm-hmm.
your any one single cord and plug connected equipment on that branch circuit can't be more than 12 amps. That's 80% of that. Or on a 20 amp circuit, it couldn't be more than 16. So
Mm-hmm.
if you had 16.1 on your
20 amp
requirement
circuit.
on your appliance, okay,
Yep.
it would have to go on its own branch circuit, and it would have to be a 20 amp circuit in that case.
Yes.
Okay, so that's what we're going to refer to as the 80% rule, or sometimes we might look at it from the other direction, where you're sizing up the circuit in order to, because you're starting with the load requirements, and you size it up 125%.
Mm-hmm.
So that's the same rule, the 80% or the 125% rule. It's just looking at it from a different
So
direction.
what you're saying there is, if we start with the circuit's rated for 20 amps, then the appliance can only be 80% of that, the one individual appliance. So it can be at most 16 amps.
Yes.
Otherwise, it needs its own circuit.
Yes.
If we start from the opposite side, if we start with the appliance and we say the appliance is 16.1 amps, then we take that times 1.25, so 125%, and we get the same thing. So 80% and then 125% are just inverse.
Yes. That's a good way to say that. Yeah. Okay. And then the third rule there, again, with 15 and 20 amp branch circuits, whether they're 110 volts or 220 volt, Um, um, if you have combination or mixed circuits, so you've got some uh, that are plugged in and they're portable, that can be moved around, and other appliances on that circuit are fixed in place. So you've either got cord and plug connected that are movable, you can move them around, or they're fixed in place equipment, either plug in or they're hardwired. The total connected load of the portion that is fixed in place, let's say a dishwasher, because you got those two little screws up there, that's fixed in place. It's not
Mhm.
supposed to be moved around. That total connected load of all those appliances cannot be more than 50%.
Mhm.
In the 80% rule, it's just one appliance cannot be more than 80%. In the fixed appliance combination rule, um, it's the total connected load of all of those things that are fixed in place. They can't be more than 50%. So to determine if you need a dedicated circuit for that, if you've got something that needs more than 50% of a 20 amp circuit, well, then you've just eliminated that from the multiple branch circuit. It has to go on a dedicated circuit.
And that's why you'd see a lot of times the dishwasher and the disposal would have a circuit dedicated to those
Hmm. Yeah.
pieces of equipment.
Yeah. On a lot of websites, they'll tell you that your dishwasher has to have its own circuit. Well, not according to the NEC. The manufacturer might say so, and then you got to do that. But um, but they didn't explain that on the list. So
Yeah.
yeah, a lot of times we put the dishwasher and the disposal on the same circuit, and that's allowable. And it's a nice, easy way to do it. So far, the code lets you do that.
Mhm.
Um, if together they were more than 50% of the load, they're both fixed in place, then one or the other would have to go on an individual branch circuit.
And then if one of them goes on another, then the remaining must be less than 80%, right?
Yes, yes, that's correct. Well, yeah, because they're usually cord connected. Now, if you were to take and hardwire it, see, there's all these little if thens, that play into it. So there's a lot of this is a very technical subject.
Yeah. But we're going to get to the non-technical part here in a bit when we can actually show them the nameplate, right? And they can
Yeah.
just sort of understand just the basic of it.
Yeah, if you want to practice that right now, I'm ready to pull that
Let's
up,
do
I
it
think.
because we can tell them everything and or they can just see it for themselves, right?
Yeah. Okay, let me see if I can get back to that to share. Okay, I believe it's this one here. Okay, can you see that?
Yep, I see the whole screen there.
All right. Let me go into this part here then. All right. Here we have this was the nameplate off of my microwave. I just opened the door and took a picture of it. Um, and this has got a lot of useful information. This is a really good practice to get into. Look at the nameplates on your appliances around your home. That's something everybody can do. Here's some information. It uses 120 volts AC. 60 hertz is what we use in North America, I think. I
Hmm.
think the United States and Canada at least, single phase. Here's some more information. 1200 watts. Now, this is a really good nameplate to start off with because it gives us a chance to look at both wattage, voltage, and a little bit amperage. Those are all three different ways of looking at electricity. The watt is what they're talking about here is the output of this is actually what you get for your money. This is not the amount of electricity that's spinning your meter. Um, instead, This part right over here is what your microwave is actually using to give you this output over here. 13.8 amps. So when we go through those rules, Stephen, number one, if you had a 15 amp circuit and it was a multiple outlet branch circuit, would this work?
For a 15 amp circuit?
Yeah.
Well, if we had so we're going to start with the circuit. So you're
Yeah.
saying there's already a 15 amp circuit
Yeah.
ran for where the microwave is.
Yeah,
and we want to put it.
It's got other things on it as well.
Okay. It's got other things on it. So since it has other things on it, any individual appliance on there can have no more than 80% of the load.
That's correct.
So 80% of 15 amps.
Yeah.
If we take 15 times 0.8 is 12. And in looking at this label here, this microwave is rated for 13.8 amps. So that tells us that we can't put it on that 15 amp circuit.
That's correct. Good job. So you just used the 80% rule to figure that out, to eliminate this from that circuit. It cannot go on that one. What about a 20 amp?
Well, this will be good. We can still follow the same example. So there's already a 15 amp circuit there. And now we know we can't use that. Right? So now we can look at it from the other direction. This is 13.8 amps. And we can take that times 1.25.
Okay.
1.25 times 13.8. That's 17.25. And so this can be on, if we go to the next common size up as 20 amps, this can be on a 20 amp circuit with other loads.
Yeah. Okay. Yeah. If you took your 20 amp, you would have, you'd be able to put something that was 16 amps on it as your highest appliance.
Mm-hmm.
And so this would work on one of your small appliance branch circuits that are rated for 20 amps. You could do that.
This would be allowed.
Yeah, that would be allowed.
Not necessarily always going to be convenient.
Yeah,
because
not
the code is
necessarily.
for safety, right? The
Mhm.
code's for safety.
Code
and
minimums.
We're trying to balance, that, one of our guys, he said, this is a running joke in our company. He says the code minimum is, we were talking about somebody making a hamburger and how people don't pick apart what they charge for the hamburger. They just pay the price. And so in the end, you get a hamburger that's only got 2 pickles. Code minimum 2 pickles. So that happens at least once a week in our discussions. So the code is about the minimum for safety.
Yeah.
And we're trying to balance that with convenience for homeowner or tenant, whoever's living there. And so just because that's allowed for minimum safety doesn't mean that it's going to be convenient, because if you have a microwave now and you also have a coffee pot, and those are each individually allowed to be on circuits with other appliances. If you're using them regularly, if every morning you make your coffee and you warm up your breakfast burrito, you're going to most likely have an inconvenient morning on a regular basis.
Right.
And so what do we do then? I mean, how do we balance all this? Because we keep getting more and more electrical loads.
Okay, so you could run another circuit over there, and you could put, since the individual branch circuits don't have an 80% rule, they don't have a 50% rule. All they care about is that they're able to at least match the requirement of the appliance. So we could run a 15 amp new wire, put a new circuit breaker in the panel, and supply this microwave on that if you were going to do that by yourself. But then you got to think down the road a little bit. Maybe you want to bring a 20 amp because maybe you want to get a bigger microwave that'll make your food hotter more quickly in the mornings. And who doesn't want that? So there's that. Anyway, let's see. Okay, now there's one other thing. What if you got tired of your kids taking your microwave out of your kitchen or somewhere and taking it to their rooms so that they could have a party in their room or downstairs or something? So you screw that down to the countertop so it cannot move. Now it is now fastened in place.
Hmm.
Okay. Now you have to go with the 50% rule. So on a 20 amp circuit, small appliance circuit, you've just changed things dramatically. Before, this particular microwave would have been fine on a 20 amp circuit with other things as far as the code goes.
Hmm.
And you may not have much trouble with tripping breakers because it's a medium-sized microwave. Um, but now you fasten it in place, so now it has to obey the 50% rule, and it is over 10 amps.
Hmm.
So there you just created an issue where now you have to bring a 20 amp circuit over there or a 15 amp circuit just for this microwave. So that's how these rules work.
Well, honestly, it seems kind of silly when you first hear it, but it seems like that's a rule that respects the next homeowner, right?
Yeah. Yeah.
Because you've put something there that's not easy to move. You've put in some kind of appliance that's meant to be there. You made a special cut in the counter and you put a, electric cooktop, some special thing there. And so
Hmm.
that's not hard to that's difficult to move. And so that's just more of a respect to the next homeowner that,
Hmm.
hey, this electrical system is sound for the way that this is fixed.
Very good. I don't know what our time is getting to be. Did you want to go through some more uh, s-
I think
some more
that
practice, or is that good?
I think we basically covered the process. I would go ahead and say, though, just a couple other considerations, because if you can look at this label, the electric appliances are going to have this on it. So sometimes the coffee pot, it has it on the bottom. Sometimes it's on a sticker. Sometimes it's like printed into the plastic. Sometimes, like on your oven, if you open the door, it's inside the door. So sometimes the places where the labels are put is a little bit inconvenient or hard to
Yeah.
find, but they're there, unless it's just so old that they're worn off or something. But just keep in mind the not only this process for each individual appliance, but also the combination of what you're trying to put on the same circuit and where you're placing them. So this is
Mm.
particularly pertinent in the kitchen, which is why we keep going to the example, because we have so many electric appliances that when you lay out your kitchen, especially if you live in an older house, you're probably dealing with a kitchen that has two circuits if it's an old house. Some
Hmm.
some may even have one. But knowing where those circuits are, which receptacles are on which circuit, can help you place your appliances in a way that's not going
Hmm.
to inconvenience you later.
Yeah. Very good. Um, do we end there, or there's one other thing that I want to mention.
Okay.
This is a Pampered Chef um, deluxe air fryer, one of our favorites appliances, and it doesn't have an amp rating on it. It's just got a watt rating. So what we would do here is take 1700, divide by 120, so watts divided by volts, and that would give you your amp rating. So I don't have my calculator up, but you would do that calculation, and then you would use that to go through these steps to see if this needs its own individual branch circuit. Do you,
Yeah, and that's important to note because a lot of them don't have the amps marked on there. So if you forget that, you can quickly look that up how to get the amps. You'll need the voltage and the watts, right? So
yeah.
that's excellent to point out. But yeah, that all gets a little specific, but I think it's pretty helpful for people to get a better understanding. In the next video, on our third final video on this series, we're going to go through just in quick fire I'm going to do quick fire. It's going to put David on the spot. And we're going to say each appliance, does it need a dedicated circuit? Yes or no?
Mm-hmm.
We'll see how quick it is. It might not be too quick. Well, we have too much explanation on everything we do, right?
Yeah.
But that's
There,
okay.
it's technical. Yeah.
That's why we're doing it. So thank you guys. Join us on the next video and we'll go appliance by appliance and see which appliances need dedicated circuits. Thank you. See you later.